But I would like to stress the final part of the presentation. It went a bit fast during the event because I think that for you the most important thing is the scenarios that we're going to cover in the short term, and maybe some things we're putting in that are interesting, that are more technical. So this is a summary of we have at the moment in GeneXus generators, and maybe this cut will seem strange to some of you. That is why I wanted to explain it. Right now you have Java, .NET, and NetCore, and these generators generate web. But actually there are two generators. One is a backend generator that generates in .NET, etc., for all of these platforms and clouds. And all of these generators include a web generator. That web generator, you may ask, well, what does it run on? And some time ago it didn't matter, but now it does, and it runs on a framework that we have for web execution. Instead of Angular and other things, we implemented the framework in order to be able to make the generator. So the generator is included. One of the things that we're doing with Angular is that the web generator is a part. The front end separates from the back end. It's something that we already had with the generator for smart devices. You may say, I don't see it as a front end, but but in the way we implemented it is more or less the same, because a generator for smart devices in US or Android, well, the application gives you a presentation in user interface and connects to the generator to bring things, which is the same thing that a web generator in React or Vue. So what we are doing with this generator is putting it where it goes in the front end. So this is what I meant. The framework is not going to be discontinued, or its development is not going to be stopped or anything like that. We'll continue making it and making it evolve according to the technologies we can put in. This framework is older than internet. It was born with internet. Since it was a website until the web app, we went through all of the steps in the cycle and developed them according to the technologies for web that were coming up. Why? Because there was never, like in the backend, a technology with which you could say this is the technology on which we can step and be confident that in the medium term it's something that is going to last for a long time, and the people will want to adopt it. There was never this alternative. So we said we are going to develop our framework and continue developing it. But now, a few years ago, others came up, like Angular, which is one of the oldest one. It's 5 years old. In the first versions, it was kind of precarious, but right now it's very good. And now React, and also React and Vue. These are the most important ones, the three most important frameworks for front-end development. With this, what we do is they run in the browser, to make it simple. They can run in other places, but these run only in the browser. They are not good for backend. They run only in the browser. Do you have any team working in Angular, one of these? So I will describe them to give you an idea in alphabetical order because there's no preference. Angular, well, it's easier to say what they do, what is common to the three of them and what they were born for. Angular, React, and Vue, what they do very well is the rendering of the DOM. You would say, what is the purpose of this? What do I care? The rendering of the DOM In old applications where a post went and a page came, everything came back. But as time went by, we developed applications that change small things in the screen. Now, how is this done in HTML? The HTML, when the browser loads it, converts it in a DOM, which is a model used for the rendering. Now, the DOM has not been thought to be updated efficiently in small parts. It's a problem it has. So what they invented, between commas, is it frameworks, its libraries. So when I want to update something, I have a date, for example, and I put something in my model and I want to have it on the screen. Instead of putting the DOM and looking for elements and replace them, what I do is to use this virtual DOM. It's a structure of memory that each one has that is very efficient to update. And then in order to move the real DOM, what they do is that they have a lot of optimizations and strategies so as to make it efficient. This is what these three frameworks do. Angular does more things. Maybe they'll tell you it's a framework or not a library, but they are good at what I just explained, and this is what we want them for. That's the main thing, the technical value they give us. So these are the things that are common to the three of them. What's different? Angular, in the first place, is a framework because if I want to make a web application, it's enough with Angular. It gives me the tool chain, the update of the DOM, and if I want to make a single page application, it gives me the router to browse. It gives me a status management, everything I need. I may want to use other things, but if I want just one framework without adding external libraries, it's Angular. S- And besides, it's program only in type free, so that's why it's so successful in corporate, because they want just one provider and not many with interdependence between them. So this one is updated quite frequently, like 2 versions per year, and they all have breaking changes, but it's just one. The other thing is that it is programmed in TypeScript. So I, who come from Java, etc., I feel at home because it's a JavaScript oriented to objects that is made by Microsoft. So those who intervene there are the ones that made CJAR. So it has the GitHub. So it has the same things. If you come from GitHub, it feels familiar. So I think that this is what makes it interesting in the corporate world. The other one is React. In the middle, React, from the point of view of web development, is on the other extreme. It's the most popular among front-end developers. Why? Well, it becomes obvious after you understand it. You would say, why does Angular does not have appeal in the front end? React is a library that only solves the problem of the rendering of the DOM. If you want to add, as we said today, browsing between pages, you have to add a router. You have to look for a project, integrate it, and if I want to manage status, I have to have a solution in order to manage status and integrate it, and the team has to put up the technological stack that it's going to use to implement an application, including React. Vue is the same thing. It is not a framework, they say it's a library. And to do something with this, it's not enough to do something with React or Vue. I need to add other things. Now, front-end developers that come from JavaScript feel at home because they come with libraries and they have been developing things in JavaScript, and it's pure JavaScript. And so for front-end developers that are used to having their solution, their stack, and to integrating things and controlling the versions, whether a new version of our library is still compatible. Well, for us, it may be confusing, but for them, it's clear. So who were developing front end find that React is just a library that they integrate and that solves some problems. And it's the oldest one. Leaving Angular aside, it's much older than Vue. Angular is from Google and React from Facebook, to set the context. So that's React. And that's why it's so successful among the front-end developers, because they just follow the development path and they integrated a new library which solves a gigantic problem. Vue is the newest. It doesn't belong to any big corporation. It's a former Google developer who did not like Angular JS, which was the first one, and which didn't like much either, and said it can be improved. And much later, and based on many things that he took from React, he made Vue. The philosophy is the same as React. It is programming in JavaScript, and it improved some features of React. It's much lighter, which is very important in all this, easier to program, and is the one that is being more widely adopted. And those who use Vue fall in love with Vue, and that's what they want. They don't want React any longer. And it's very successful in Asia. I don't quite understand why, but it's been very successful. Now let's get into the generators. This was an overview of the technology concerning front end. What do we have? What do we want to use? Which are the three previous one if we want to make generators for the different kinds of front ends. The generators are being made on the basis of three pillars. One is the web components. Does anybody know what web components are? Well, both React, Angular, and Vue work on the basis of components. I build components that I put on my screen, and my web page, my web screen are made by various components. Now, these components only run in an Angular application, or React only run in an application React. There was an initiative from W3Cs to develop technologies for the browsers so that these components can be built independently from anything else and run natively in the browsers. So, up to a certain level of complexity, it's much portable to make components with web components that if working with Angular, I do it with Angular. Imagine that I have a page where I want to do a search. I put an edit field, a button, and I put an input, a button, and an image at an on and off, etc. Assume that I want to put this in another page. I have to copy the input, the spinner, and the button, and copy the JavaScript included, etc. With this technology, what you can do is to encapsulate all this in a control that is mine. That is to say, I'm extending the HTML. I create a control attack search that implements these controls, and I cable the JavaScript so that it works as I want, and then I put it in any of my developments, native in my browser, and in that case I don't need Angular, Vue, etc. And what we are doing here is a library of web components that implements all the controls that GeneXus allows to design. When you put a control on the screen in GeneXus, we have one implemented here, which allows us, obviously, that if I have a generator that is Angular, React, Vue, or whatever, all that is already done. But when we build a new generator, we have the cost of all the cabling of the infrastructure, the screen, the controls, etc. So this is one of the pillars of the generator. It is independent from Angular and from all we are doing for front end. And we are going to share it obviously with all generators. The second pillar is what we call the standard functions. You probably have heard about Java's standard functions, which is the other part of what you do in GeneXus. When you write the events in GeneXus, you use functions, trim or location or sharing a date, and we call them standard functions. They used to be only functions in GeneXus, and then they evolved, and they are objects, type of data, functions, etc. The option was also to do it in Angular Reactor View or not to do it in any of them and do it in TypeScript and JavaScript. That we can share among all of the generators, even the framework that we have now. The objective is to start sharing all this, that the code is as shared as possible. One of the objectives is that it is lightweight. In the web, everything has to be lightweight because we have to bring it almost every time. And also these classes are partially generated from those internal to GeneXus. We take all the objects there are, all of the types, and we generate a skeleton of classes and methods where it is necessary to complete things, and the developers complete the behavior of each one. So in the future, if we need a generator that is not JavaScript, we can take advantage of all this. We have a project that is going to be open with the standard classes. Nowadays we release an upgrade and then we put up the standard classes. But in this case, it's the other way around. The other way around, we release a standard generator and we include the standard classes in this generator, the ones we have. And the third pillar, obviously, is the generator itself. With the generator, we wanted to change, or rather to make generators that would be easy to modify. Why? Because we already have a technology for generators that we developed about 30 years ago, because there was no technology for generators when we started making generators. We use Prolog that requires a mindset to work with it that is a bit different, and it's very crude. You have to change the mind. Oh, very, very raw, sorry. So in order to work with the generator, you have to get into this way of doing things, and it has a quite a steep learning curve. So in these 30 years of development, other technologies have come up in order to generate codes that are more conventional. And we went twice to Europe to a convention for the generation of codes, and we introduced GeneXus, and they didn't understand very well what Prolog was. So basically, we are trying to use technologies that are conventional or traditional to generate codes in this generator, which allows us to do some interesting things. Luciano in the event was telling you about the modification he did with the generator for mini applications. If you have questions afterwards, I will give you more details, but I'll explain quickly that you make a panel in GeneXus, and there a metadata is created, which is the description of what has to be done. Then a series of transformations are applied to it. For example, which are the variables that I need to run this object, or to make this object run in Angular or whatever target, which controls I have to put on the screen. All of these transformations, you add things to this metadata, and at the end, there is a templates motor that produces the final language, which could be Angular in this case or others. So these transformations are independent from Angular, React, or whatever. As you see, we are generalizing much more what the generators are. To give you an idea, these transformations are made in GitHub, and the templates engine is Screen Template, which is something that is very well known in templates. So what do we generate? Let's start getting into the Angular and see how it functions. What we generate, unlike what we have right now with our framework, is an application that has three layers. The first one is a presentation where the UI is presented, as you will see in a moment. Then and there is a button. So I press the button and a code is executed, which is in the middle layer, which is called component. The problem is that many things are called component, but they are different. In Angular, that intermediate layer is called component, but it's not a web component, it's something else. It's the behavior. It used to be called the code behind. This is the code behind. It's what responds to the UI. And then there is a connector. We call it like that, and it's just a representative of the data in the client. All this runs in the browser. So eventually this will ask the server for the data, or it can do more sophisticated things like keeping it, maintaining it, or having a database like in an offline application for smart devices. So in the UI layer, we are using the web components, and for call behind, we are using this API library to implement the functions, which are all generic. So why do we use Angular? We use Angular for what Angular is good for, which is the binding between the controls and the data. What we do is tell Angular, this is the web components to use, and it has a binding to this data model, to this element. And then we update in the component with all of these functions and some internal things that are done in Angular. And we review the data based on the component of the application, and Angular is in charge of modifying the DOM and the screen. It's what it does well and quickly. So this is a quick overview of the architecture of the application. All of the generators that we make are going to follow this architecture because React does the same thing and Vue too. So we are just taking advantage of this characteristic. In Angular, we take advantage of some others because, for example, the toolchain is good, the packaging too. Now, given this, we have an Angular generator, which is quite advanced. Actually, the application for the meeting was created with Angular, but we wanted to start the React before finishing the Angular for technical and strategic reasons. As you may have seen, we are doing a big generalization of everything. So we want to start stressing it to see whether it's correctly done. So Angular is running in the development, and React, well, we started about a month ago with the development in React, and there are things that are already functioning. And we found things that have to be generalized and solved, and that's what we wanted, so that afterwards, if we're going to have a view when the time comes, we know that we can develop it in a short time. And then, I don't know whether you looked at this application or downloaded it. I don't know whether to show it to you or not. Maybe we'll do it at the end if you have questions, more technical questions about a specific behavior. Well, with regard to the code that is generated, we have two design criteria. One is difficult. Well, actually, they're both difficult. two important and difficult criteria. One of them is a performance, which is by far the most important criterion. We wanted this generator to be built in with a very high performance, and for this purpose we had to solve several problems. And the second thing is that it's not necessary, but we still want to do something very ambitious. We want the program that we generate to be undistinguishable from one written by a person. It is easy to say, but very difficult to do. It was one of the design criterion that we are applying, and both for the nomenclature of variables and the way we use them, and in trying to see if I put something on the screen and then use it in the code behind, that they're not things, too many things on one side or the other. A generator tries to solve and foresee all of the cases, and what happens is that sometimes there are things that are put there or that are there and are going to be used, and that's what we want to eliminate. And it's interesting work, at least for me. So this is a design object, and the other one is a performance. This is a lighthouse test. You all know it, I imagine.
It's a sort of standard right now regarding the performance of applications. Lighthouse is, by default, it measures the first download by default, and that's the one that hurts the most. And that 90 there is spectacular. When we started, it was almost all red, less than 50. But we had to work on that to do it in that way, to make it work. But what I wanted to say is something that is important, and if you go with GeneXus and you are going to present it, and it says, well, I'm going to go with Angular. But the fact that you use Angular or React or Vue, there is some sort of myth that just by using it is going to be fast, and you're going to get that. And that's a lie. It's absolutely false. It's not possible. And in fact, to be able to do that, we had to do lots of things that have nothing to do with Angular. Now, Angular gave us that speed in UI, and you could see it, but before having Angular give us something, we had to improve lots of things. And that's going to happen to any team developing an app in Angular, React, or Vue. And these are some of them. I don't know how I'm doing with my time, but let me tell you about some of them. I couldn't go over them during the event in my talk. In the first place, an Angular app is that you have to bring it in all. The first time the user sees it, but the most critical user is the one that sees by chance. He enters the first time, he doesn't like it, he would leave. If it takes a couple of seconds and he sees everything blank, he would leave. Now, Angular packages everything, and you download the app full. An app like this one in our event of 100 objects, you go in the first time, it brings it down all. It's megas, just to give you an idea. With Angular support, with generated components, they are unified, compacted, and it's megas. So one of the things you have to do when you are developing an app, independent of what you're using it, what you're doing it with, you have to set up a package that I'll download just to show the first screen. So the minimum thing that it shows me is the first screen, and the rest comes afterwards. That's the easy load, the lazy loading module. We have everything is shown on the first page. The first time you get in, you download it, and as you go along the app, the rest is downloading. That's an optimization that you have to do, that you always have to do, whatever you use it with. That's an invention. Well, it's not ours, but the name is our invention. And it says if I've got several components in one screen and the complex is screen is complex, and that's the one that hurts the most in terms of performance. Many of those components are outside my view. Now, when I bring in the screen, I bring all that, but those that are outside my view are not loaded. I'm not going to go for data. I'm not going to execute anything to load them. If I'm going to look for data, they are going to be competing with the other data searches, and so what I do is I defer that. If you look at the event application, you would load the second screen. You have GX29, and you make a scroll up. You won't see it. All right, lazy loading images. This is a very well known technique. You know, I'm not going to wait for all images then to be loaded. I will show one, and then the rest will start loading. Now, page lists. Not in the mobile application because it's offline and it brings in down and it's synchronized. It's not page, but in the event app, if you scroll up, you will see that it's paged. So you scroll back, it's been reduced because it brings in more things. That's a GeneXus feature. It has nothing to do with the Angular generator. It's something that we decided to do, but something that you have to do to make it work fast, because otherwise that screen would take a long time. It takes a long time, not because of the data it has to bring in, but also because it has to design them and draw them, and that's what takes time. This is a tree shake. It's a fancy name for something that it's something that we already know. It's to eliminate, it's to delete dead codes. As I said, you have to download the app to the browser. Now you download it to the browser. Imagine that you have an app, you have a library like the standard function with 400 functions, but you only use 3 because it's very small. You're not going to download 400 functions in JavaScript, just 3. And so there are mechanisms in the tool chains of Angular that can cut it out. They check what you're looking at, and they only choose that when packaging it. That's what tree shaking is like, shaking a tree, and you only get what you want to have on the tree. So that's the metaphor. That library has to be implemented somehow. It's not any library that you can make this tree shaking. It has to have a particular implementation, and we did it following that criteria. Then something else, the question of minification. When JavaScript doesn't go in the way you've written it or as the generator had generated, but it's minified. That is, it takes the enters, all the characters that are extra, it reduces the name of variables. It's done in a program that is in the tool chain outside the generators. It's something normal that you do in any app that you're distributing. Now we realized by analyzing this app, because once we compile it and we minified it, and we went in to see what was there, and there were things that were not minified. So we had the chance of doing it. We added a distribution mode in the Angular generator in charge of minifying these things. I thought that we had saved 10K, but in the event app where it has 100 objects, the reduction was 60K of things that the minify doesn't minify, and that we did. And then just now, at this stage, I start using Angular. Just now, I'll start a feature of Angular that gives me speed, to give you an idea. I mean, everything you had to do for the application to work. And, well, it's a differential loading. Angular 8, Angular 9 is going to be released, but in Angular 8, there are modern browsers and others that are lazy. The modern ones implement many functionalities. For the old ones, for the legacy, that haven't got that functionality. In the JavaScript that we distribute, we have to include some libraries that implement them. And so what Angular is doing, as from the Angular 8, you compile the application and generates 2 packages, one for modern browsers, some others for older browsers, and a loader. So whenever I execute my application, Angular would look what browser I'm in, and it would download the smallest one. If I'm in a modern browser, it will know that it will have to download the minimum. There are other things about tree shakeable things that Angular does on its own, and so on. So these are this is part of that optimization, because that's the goal of Angular and everything we do in the web. I mean, optimizing is critical, and that's what we are doing. Now, all right, full stop here about generators, and now I'm going to talk about scenarios. Now, what do you think this Angular generator in the short term is going to be for? Let's say from now until the first version, let's say. All right, to that end, I'd like to explain something to you, and perhaps we can discuss it more deeply later on if you're interested. This is the type of applications that you can generate for the web. It's a bit fancy, I would say. I would like to map this so that you can see how we program in GeneXus. I'm going to divide web applications into two. These are just names, right? They look like many of the names we know. Now, so we have an end user. It's also called customer-facing application, I think, right? Armin knows that. These are applications for the final user, for the end user. Let me give you an example. For instance, eBay. It's a web application. You go in, you look for something, you search, and you say buy, or you have a cart, and that kind of thing. Or Amazon, right? These are applications that are complex, but are thought out for the end user. Which isn't an expert in the application. It has to be easy to use, simple. It has to be fast. So that's the type of application where we want it to work fast. It can't take any time. If it takes time, the end user will go somewhere else. And then the back office. Now the back office is the other type of application, which is the internal app. It's not internal to the company. It's not necessarily like that, but it's the back office. For instance, purchase order. The one who's going to use this application is an expert user, and applications are complex. They have a complex input, and to use it, well, you have to be trained, you have to know. And so that's the other type of applications. So given this division, then I'd like to show you how our generators fit in this type of applications, in which of the two they fit in if I want to make an application. Now, for end user applications, you can do it with our web generator. They model with web panels. And those web panels and the transactions are powerful enough, have rules. There are many functionalities that can make end user or back office applications. In general, with the smart devices, you can also have back office, but they're not that expressive in what GeneXus can program. If in the GeneXus model you use the SD panels, now with an Angular generator in its first version, it is designed and based on SD panels, and so it's going to be more apt for end user type of applications. In the future, we're thinking of making these two programming models to converge so that it's indifferent. But in its first version, the Angular generator to program with it's going to be using SD panels, the smart device panels. Now, let us look at the scenarios with this first version of the generator. Number one, of course, if you are going to be programmed with SD panel, you have an SD application, you'll be able to convert it to the web. And I take my SD application and I convert it. Now, what do I do with my screens if it's Android or iOS? Well, we are adding a configuration property to the generator. We did it with the event application. You can configure the generator in such a way that when there is more than one possible layout, you can give it a hint, and you say, well, if this panel has Android and iOS, prefer just prefer iOS. You tell that to the generator, and the event app is based on the iOS application. I mean, it's the iOS part of the application of the event uh, with Angular. So that's the first scenario. You can convert very easily an app that it's already working in smart devices to Angular as we've done it before. Now, the other one has to do with a desktop app or the eBay, or Amazon. So what are we going to do there? Well, all right, you say, but the screen is larger. You have a large screen or a bigger screen. And in that case, what we're doing is adding in the programming model of smart devices with screens for any platform, screens for Android and iOS, we are adding a web screen, or we're going to add several types of sizes of web screens, and there you could add, you say, well, this is my screen for my Angular generator, and I want iOS to generate in this way, for Android like this, and for Angular in this other way. And then the other scenario, which at the beginning we didn't see it very much, but it's really there, and we don't see it, but it does happen. And it's that there are many companies that have their own Angular, React, or Vue machines working, and they are already being integrated with GeneXus. They are already using GeneXus simply because of circumstances, or simply because they've already got the application done, or for whatever other reason, but they've got a machine doing that Angular. They've got a base built with Angular, and they want to use GeneXus for the back end. And so what we are doing with this generator, if you recall the architecture of those three layers, it's a connection point that is far simpler for those that are doing that. So if someone, just imagine, if a team has made a product made in Angular, but it wants to use something done in Angular, would say, all right, no problem, use GeneXus for the part you need, generate the app in Angular, and then by using that third layer, which is the representative of data, put yourself on top of that, and you have access solved with your application made in Angular. So I think that scenario is a scenario of, all right, we say the app has many things done using GeneXus, many screens using GeneXus, and some screens that are core, that are very important for the customer to do it in one particular way. You can integrate it in that way because it's legacy, because you have to support it because of whatever reason. That's a scenario then that we are also seeing. Now, what's our roadmap in this? Well, we are launching a closed beta where we are going to have application batches, small application batches. We're going to generate applications that are already preferably light, that are already published, that they are validated, let's say, they're functioning, to go to Angular. We're going to get early adopters, beta tester who want to go into that test, and we're going to convert it to web app. We're going to have an open beta in the first quarter of 2020. After the batches, we're going to open it for the last run. It's going to be released in the first quarter. So that's the overview I wanted to share with you. That's what I had to say. So any questions or anything that you would like to deal with more deeply, we can certainly discuss it here. Thank you. Can you show the last screen, please? Have you got a question? Well, I was discussing this with Luciano. He showed me the application in WeChat, but I didn't understand how he could change the generator. All right. What does that mean? Well, it means that, all right, imagine this. look, we aren't sure whether we're going to release it in this way. I'm telling you what he did now, what we've got now. You've got a smart device generator, and you say, please generate iOS, yes, generate Android, yes, generate Angular, yes. And so what he did was to generate WeChat mini program, and he said, yes. Have you seen that pipeline of generation with the transformations? Well, what he did was to modify that, particularly the last part that are the templates minitized, so that instead of the generator doing Angular, to do it with WeChat. So what he did was, at the end of the day, using the Angular generator, he took away the Angular part, he put in the mini programs, and it worked. And he did it for WeChat, for Alipay, and I think for another one. They're very similar. In fact, it's not that. Now, another characteristic of this generator is that part is distributed. Those templates are distributed with GeneXus. So if someone wants to modify something about how that is generated, because something that you can't do in Prolog, if you need to change something, really the generation output, well, those templates are going to be in a directory of GeneXus. You go in and you change it. If someone would like to do what Luciano did, you could. Are we going to support that? I don't know. That's not clear. We don't know really what we want to do. In principle, we do, but I can't really tell you. It's not my decision, really. I'm a very humble. I think that it could be useful for integration. I don't know how far we want someone to use this to make another generator. I don't know. I don't know how far you can get. Well, Luciano did quite well, in fact, because he did a generator on that basis. But for other things, you'll have to go into the transformations that I mentioned, and that's not public. It's not that we are releasing a generator for anyone to modify it. That's in the templates. You can change a template. We've been taking it away from Prolog, but there were some templates in the Prolog generator that you could modify. But it's just that, only that now everything is far more based on templates. So transformations are some kind of complex specification that's far more complex than the generator, because the specifier, if the spec is of a much higher level. Transformations get you metadata. There's practically the generator practically the program to be generated, but it's abstract.
¿Qué pasó? No quieren la oportunidad.
Well, if no one else takes the floor, I'll do it. I would like to go deeper into the metadata and transformations and how this thing works. Well, that's the technology of quite conventional generators. That is, to generate a code, a program, let's say, what you usually do is you build a tree. A source, an if is a node with two children. What you execute when it's true and what you execute when it's false, and in that way you chain all the constructions of a program. So you start with a metadata that has a tree describing what you put in the events. That is in GeneXus. It's written in GeneXus. So we started transforming that to take it to something more generic. And so we start converting this tree syntactically, adding things until you get to a moment where that tree, that syntactic tree, which is an abstract and there's no language, it's a code tree. You can take a template engine and put an output in any language. Now, in this case, in the case of this generator, there is no Prolog. We would use Prolog in previous generators with another design. Prolog is a spec, is the SPC, a high-level SPC that you can see somewhere, and it's as if you had a giant tree, And on the basis of that spec, we do throw that spec in the tree, and what Prolog does is to cut out that tree to generate that part of the code. We're very abstract now, but we've become very abstract. But that's a very simple explanation about how Prolog generators work. This is something else. Well, that's why you're using the backtracking in Prolog. Yes. Well, yes. Prolog is like it's like programming with questions. If this happens, and if this happens, and if this happens, I go on. Otherwise, I will stop and take another road. That's what Prolog does. So in a way, it's like going around a tree, and Prolog is used for that. It's like a very, very big tree. At every point where you get, you have to decide whether you go on or you take another branch. Why do you have to have transformations? Well, because it's easier. It's easier to modify because architecturally speaking, you have the specifications explicited in a transformation. In Prolog, if you are neat and tidy, you can do it. But you have your hands loose to spaghettize it. And that's a constant work trying for that not to happen. Now, with this, if you want to add a functionality, what you do is you add a transformation. You want to take it out, you take it out. Now, in Prolog, to do that it's far more expensive to do in Prolog. So every transformation reflects an intention of what you want to do. And that mapping, transformation intention is critical to be able to simplify. I mean, you build a generator in many little pieces, and that's what you want to do in Prolog and what you have in Prolog, but it's far difficult to keep it as such because it's more expensive to keep a Prolog like that than using these new generators. Furthermore, it's easier. Let's suppose I don't know if I'm going to open it, but let's suppose we want to open it and someone wants to include a certain behavior of the generator. It doesn't really need to know what the other transformations are doing. If you do it with Prolog, you do need to know. What you know is that after this transformation, the metadata data will have this size, this information, and then you go on. You needn't know what the transformation is doing to get in. In Prolog, there are parts where you have to know, others you don't, but in some you have to know. Now, from what you said, what's the idea of putting Vue and React if Angular seemed to have everything? What's the purpose, or what would be the advantage for us? Well, that's a good question. Now, from the technical standpoint, I would say that there is no major advantage, whether it's Angular, React, or Vue. From the technical standpoint, what we need is to update the DOM quickly. There are shades there. React is lighter, Vue is much, much lighter, and that could be interesting. If you remember the list of automation things, we are adding more optimization given by the platform, and that's good. Now, of course, it's far more important to do everything you had before, all the optimizations that we made and that the platform wasn't giving us than the ones the platform gives you. So the real value there as regards speed from between Angular, Vue, and React, well, we haven't got it. But what we do know is that there's a certain, how can I say, but I don't know if it's commercially, but since each one has its own public, and it's quite likely that they're going to be programs without any criteria to tell you, as it happens now with Java or GitHub, someone would tell you, well, this has to be done in Angular or in React or in Vue. Well, because, my team is React or whatever reason, it could happen. So in that case, we could either say, oh, no, you have to use Angular because it's the same and try to persuade people, or we give them React and that's it. So that's the criterion. It's as if there were different targets that are quite different. It's quite separate. If I go to Angular, I attend Angular groups, and among them everything is fine. It's all right, but each one has a certain hat on, and if they want to go to somewhere else, it's not. We have to be in corporate. and that's Angular. In the front end world, it's a world that it's difficult to put a foot on. Um, that's React, and Vue is going to be the latest landmark. Is the one that is growing the most by far, and it's good. But we don't know whether that's going to be a mainstream or. But what we do know is that with our technology, we can generate it without much additional cost. Now, this can't be used together. It's like GitHub and Java. Uh, well, it doesn't. It has no meaning. I mean, no one would like to do that unless. Well, there are certain scenarios where perhaps that's the case. Do you remember what I said about the web components? It's something new. It's independent of Angular, and it can run on anything. Now, that's been taken too much to heart, at least people from Angular. And what Angular is saying right now is that an Angular component can be turned into a web component. I don't know the state of it at present, but version 6 or 7, that's when they said that. And I do. I can't convert it to a web component, but to do so, I need Angular support. So it invalidates. I give it a web component structure, but I need an Angular package. And they said, that's not going to be different. So I write a component in Angular, and I have a web component. Now, we are not there. We want to do it ourselves, not to do it in Angular to share it. But that scenario, and if that happens, someone could write a component in Angular, convert it into a web component similar to the ones I've shown you, and use it in a real application. That's quite far-fetched. I mean, I can't think of it, but it may happen. That's a scenario that may happen.
¿Más preguntas?
Los generadores viejos.
In the case of all generators, so what's the idea to take them where? Well, the idea is that you take the prologue. No, in prologue there are many things that cannot be taken out. A lot of behaviors are very costly to take out. I'm just thinking for myself, but there are things that are not clear. We don't know exactly in which direction they will go. The thing is that the web generator will be kept as long as there is an install base, as we did with all generators. But on the other hand, the objective is not to discontinue it. We don't want to say, well, we've gone this far with the framework and that's it. We are going to continue developing everything that we develop in GeneXus, because right now it's a most important generator, and we believe that it's going to be so for a while, and eventually they will become Angular or React, but it won't happen in the short term. The web generator is the one that comes with the botnet and with it's our main Java, and we continue optimizing it. We add PWA and many other things, and we are doing a lot of optimizations like the one I just showed you in that generator, and we'll continue doing them. Besides, we are going to have the other generators. The concept with the other generators is that they are separate from GitHub and Java, etc. It's like they are separate, like the smart devices, which is the road of less friction that we found to add this technology. Also, one of the advantages is that it has 3 layers. Yes, it has several advantages. From the point of view of the architecture, that is the advantage. And it's very easy because it's more modern, and we applied everything we wanted, everything we learned with the previous one in this one. So it has 3 layers. The UI handling is different. We use new technologies. So it started like a research project and it became a generator, and we're doing well. We learned a lot from the other ones. And we are still continuing to develop the others and will continue to do so. But the new generators, well, uh, they had prototypes at the beginning, and that's how it started. But now we've brought it down to something more commercial. But basically, it has everything we always wanted to put into a generator. And I understand for that for the back end of the applications, you will continue having the others. Yes, it's very clear that this is just the front end, and the back end is working perfectly, and the web generators also are working perfectly. So we will keep them. Now, some people say, well, they ask for a project and it has to be in Angular, and this is going to happen more and more. I have another question. The early adopters program, are they online applications? So as you have for SD. Well, it's part of the selection. The events application was offline, and you see how it works, and it flies. All of the questions asked offline work on so online. I- The process of choosing the applications has to be considered carefully, but it's not using a local database. It stays online. Yes, we tested it with PWA, of putting in PWA. This one actually has PWA. You can install it in the telephone as an application and it runs there. It was a kind of trial we made. It's not built in the generator, but you can do it in Angular with 2 commands or even one. You have to add the icon and things that we'll have to put in GeneXus, but it's quite simple. We even tried configuring it with PWH so that it has a local cache, so that once it brings the data, they remain there, and it's much faster. It flies. It's it's ridiculous. It's built in. It can be given by Angular if you want. So that's the way which it has been programmed. We took it out finally because we didn't have a refresh policy in the generators, and we didn't want people to remain with all things because we could not generate the policy of refresh so that it worked well offline. But what Angular also gives us, as well as other new languages, is that they bring us closer to PWA and other technologies that it's interesting to have nowadays. They have been conceived for this purpose. From the beginning, they have been conceived to work well with all of them. We have PWA, but we had to make it work.